So this article is related to nonlinear formation control of drone swarms with collision avoidance using the MATLAB. So in this article, basically, I have just used the scientific method, which is basically Lorentz type chaotic dynamics. Lorentz was one of the scientists who proposed the collision avoidance behavior of the individual drones, and the consensus-based algorithm control algorithm is designed to achieve the formation of flying while a repulsive force is incorporated to prevent the collisions between the drones, and the multi-board formation control has been an active research area due to its application in surveillance, exploration, and cooperative transportation. So the stability of the closed-loop system is analyzed using the Lachlan theory, and the simulation results basically demonstrated the effectiveness of the proposed approach in achieving the formation of flying and collision avoidance as well. Okay, so here is abstract with the introduction. In the introduction, I have written the formation of drones, like how the multiple drones cover in terms of security surveillance, in terms of capturing of different pictures, and we need to focus on that drones in increase the coverage, improve robustness, enhance the flexibility, and however the controlling a swarm of drone is challenging task requiring the sophisticated algorithm and control strategies to achieve the stable and coordinated behavior as well. Okay, so yes, the effectiveness of the proposed approach is demonstrated through the simulation results, which shows that the drone swarm can achieve the stable formation, flying, and the collision avoidance as well. Okay, so the Lachlan-based method is one of the best method in terms of stability, in terms of in long-term asynchronous and synchronous terms, and drone swarms basically these are the drone swarm 3D trajectories according to the drone swarm animation with the time axis, different x, y, and z axis, and it also provides the bifurcation diagram for drone swarm dynamics. Okay, so the challenges in drone swarm is that the main challenging is that we need to focus on the environment where the drone need to fly, and we need to control its avoidance of collision and capture the exact pictures during in terms of multi-agent system. And stability analysis is that we need to focus on the Lachlan theory. Lachlan theory basically provides us the closed loop stability, which provide us the feedback of output results in terms of input system, and it continuously monitor the closed loop system from output results to the input and provide us the stability in terms of Lachlan function. Okay, so the comparison with the existing approach is that the existing approach provide us in terms of it does not provide us the stability, it does not provide us the collision avoidance, but in the proposed approach is provide us the switching interaction networks on flopping the stability were investigated and demonstrating the robustness against the topology variations. So next one is a problem statement, is same like I have just explained how we need to focus on the collision avoidance, and we need to predict the accurate results according to the capturing of different images, videos, and scalability, robustness, and adaptability as well. So the mathematical approach is that in the mathematical approach, I have used the complete Lorentz type chaotic dynamic model, which provide us the closed loop feedback structure in input and output are aligned to provide us the stability in terms of drone, and these are the equations used in the MATLAB to provide us the accurate results in terms of avoidance, collision avoidance, as well as the stability mode. Okay, so the methodology we have used the Ranj-Kutta method and Lyapunov theory for the simulation of parameters. Use different drones with the simulation time, step time, formation type, and the state variables are added here. Design and MATLAB simulation is that in which different drones swam 3D strategies. Trajectories are used in terms of tracking and capturing the different data in different environment for a specific time management. Okay, so this is a drone swim animation, like how the multiple drones are traveling at the same time, and this one is the x coordinates of each drone over the time. Stability and convergence provide us the stability and convergence, and y coordinates same like the provide us the stability and convergence. Z coordinates provide us the stability and convergence as well. This is the bifurcation diagram for the drone swarm dynamics, and this one is the phase space of drone swarm provide us the 3D trajectories of the drone, and results and discussion with the conclusion and references are added. Let me just provide us MATLAB demonstration. You just need this as MATLAB code for the drone swarm nonlinear formation control. So see these are the animation of drone swarm animation formation. Like for example, this is the first figure and this is the animation figure in which provide us the working of drone. See the movement of drone in different environment and different strategies. Yes, animation ended. Now it will provide us the next graph as well. See, these are the phase-space drone system swarm. This is a bifurcation diagram. Z time, Y time, stability, and the X time as well. Okay. So this is the main thing, like how the bifurcation diagram of the drone swarm dynamics, like the drones are multiply working at the same time and it needs to cover how the collision avoidance with the stability and convergence as well. Okay, if you need to ask anything, you just ask me, I will answer your questions. Thank you.